Oh, hey everybody. This video is going to be the quick video for review sheet number 16, which is going to be the last one of the second quarter. So definitely want to do well on the last one. This first one here, this is exactly what we're doing. This is chapter 5. Okay, this is exactly what we're covering right now. Okay, Felipe makes salads at a restaurant. On average, Felipe can make 12 salads in 20 minutes. Hopefully you would all be putting your fake ratio on, or your brackets on there, because you know that's a fake ratio. Okay, and then from there, whoops, you know you always got to do labels. So you know you're going to be doing salads to minutes and salads to minutes, and then your fake ratio is going to go here. And then it's like you just have to ask yourself, okay, what piece of real information did they give me, and what did they ask for? How many salads could they make in 45 minutes? Your fake ratio goes here. Then from there you can solve it from there. But that's a pretty easy question. Okay, but that's what we're doing right now. Okay? You are dividing two fractions. How can you tell if the quotient will be greater than 1 or less than 1 without doing the problem? Okay? Now I'm going to do two problems here. Now I'm not going to do the problem, but I'm going to kind of just give you an idea of how to kind of figure this out. Okay? Now right there you have two different problems. Those are two completely different problems. You can see I just got them kind of flipped. That's all I did. Now, in this question, remember, it's all about, you got to understand what division is and what dividends are. Okay? When we're talking about the dividend, that's the number being divided. Okay? So those are both dividends. Okay? If I'm taking a dividend and I'm dividing it into groups, these are my groups over here, so I'll put a G there, that are bigger than the actual dividend, is it possible for me to have a quotient of greater than 1? Is there even going to be one whole group of 9/10 and 2/5? Whereas the one below it, will there be at least one group of 2/5 and 9/10? One thing I like to do on this is I like to, even though I know it says fractions there, is just think about it like this. Think about doing 4 divided by 2 or 2 divided by 4. One of these is going to be greater than 1. One of them is going to be less than 1. Okay? So if I think about 4 divided by 2, that gives me 2. That's going to be greater than 1, obviously, because I'm saying that's what's being divided. How many groups of 2 are in 4? So I'm taking 4 and dividing it into 2 groups. Obviously, I'm going to have 2 in each group. Okay, whereas this one, I'm taking 2 and I'm dividing it into 4 groups. That is why it equals 0.5, because I'm going to have less than 1 is going to be my answer. Okay, so it's all about the dividend on that one. If the dividend is greater, then the answer, if the dividend is greater than the divisor, then the quotient's greater than 1. If the dividend is smaller than the divisor, then the quotient will be less than 1. So I basically just gave you the answer there. You just have to write that. Okay? This one here, you have to use proportions. I must see, I need a proportion here. I need a proportion here. And here, I'm going to put proportion, I don't know. I'm going to put proportion or not, ... So you can use a proportion, but I'm going to give you a pass on this one because I think you'll figure it out. When you do this one, you should be able to figure out this one. But, you know, when in doubt, use proportions on all three. But this one you don't necessarily have to, and you'll figure out why. Just remember, I would expect to see edge pieces. Okay? So my edge pieces here. In a bag of blue and yellow Jolly Ranchers, the ratio of blue to yellow is 3:5. So in that case, I know there are 3 blue. I know there are 5 yellow, which also means there are 8 total. And then just build. That's your fake information right there. That's all fake. This here is real. Set up a proportion. This right here is real. Set up a proportion. Okay? How many expressions are in this operation? How many operations are in this expression? Okay, you just have to go through there and count what's going on. I think you'll be able to figure that one out. And then obviously you need to evaluate it, so don't forget about that. Actually, that's not the right word. The right word is actually simplify. Evaluates when, say that was an x, and we said x equals 4. That would be evaluating. finding the value. Simplifying just means taking a numeric expression and turning it to become one number only. Okay, so obviously write PEMDAS, one step rewrite, all that. Okay, down here, this is chapter 5 also. This is what we're doing right now. I would hope you know how to solve this. A couple different ways you could do it. You can use scaling. Sometimes you can just tell what you're doing to go from one number to the next. But the way that you learned that can help you in any situation, works all the time, is when you multiply diagonally and then divide by the other number. And that'll give you what x equals. We just use a variable here to kind of see that it means an unknown number. Okay. Here we got quotient, sum, and difference. For sum and difference, just keep in mind that you always have to line up your place values or your decimals. Okay. And then when you're doing quotient, I'll give you a little hint here. I'm not going to go too deep into this, but there should be an immediate red flag that jumps out right now at you, and it's with this number right there. Your divisor, the one that's doing the dividing, always has to be a whole number. So you've got to take that decimal and you've got to move it 1, 2 to make it 607. Well, if you moved it 2 places there, that means that you multiplied by 100. So you've got to do the same thing here. Move it 2, add a 0. Okay? So actually the problem you're going to be doing is 3,160, and you're going to be dividing it by 607. Okay? That's just for the division part. So you'll have to do it from there. Okay, you'll have to go, by the way, you will round to the hundredths on this. On the quotient. Round to the hundredths. Okay? Okay, so you're rounding to the hundredths. So that means you're going to need to go to the thousands. Remember, if I had 2.984, I need to go at least that far just to be able to round there, because I got to look to the number to the right of it. So you got to go one beyond wherever you're rounding. Okay? This one here, area and perimeter. I think you guys, we've done enough of this. I mean, it's kind of review. If you're not sure what area is, look it up on the internet. Okay? How to find area. Just remember right here, I'm going to underline this. Use appropriate labels, because I will count off if you don't have the correct labels when we're talking about area and perimeter. Okay? We've done a million of these questions. There's your fake ratio. Okay, obviously I need to see a proportion here. Okay, there's your fake ratio. I want to know, the unknown is, how much does it cost for 10 apples? Okay, here, this one here is actually learning target number 9 of chapter 5. This is the video you're doing. So we've just done this. You're going to use a proportion on this as well. Just keep in mind that when we're doing proportions for conversions, see, we're talking about pounds to ounces. Pounds to ounces. But remember, the difference is when you're doing conversions is the fake ratio is that conversion ratio. It's the one that says there are this many ounces in a pound, or there are this many inches in a foot, or this many feet in a mile, whatever that is. So if you're not sure, look it up online. How many ounces are in a pound? Okay, and go that route. And then this right here would be your real information, so that we know that 16 is going to go there. So you got to find fake information and then cross multiply and divide. Number 9. Okay. Now you got to turn this to an improper. So we'll call this first column here impropers. Then you got to go to a decimal. Then you got to go to a percent. Okay. So if we're going to turn it to an improper, we know that we just go around the barn. So that's going to be, actually, you know what? I'm going to do a different one. I'll do 3 2/5. Okay. So I'll do this one, and then you guys can do the other one so you can kind of see. So to turn into an improper, we go around the barn. That's going to be 17/5. Okay. If I'm going to turn that into a decimal, I just got to remember that all fractions are division problems. Okay, so I'm going to do 17 divided by 5. Again, you can use your calculator on that, no problem. 17 divided by 5, and that equals 3.4. Okay, and then to turn something into a percentage, we simply just multiply the decimal by 100. Or just know that we would be moving the decimal 2 places, because there are 2 zeros to the right. So that's 340%. Okay? So, around the barn, all fractions are division problems to get that. And then to convert any number into a percentage, we automatically just move the decimal 2 to the right. Okay? So you do that for those two. Okay? This one, look back in your chapter 4 notes for that. It's all there. I think it's in 5 too, so I think we got it in both places. I know this one's for sure 4. This one might be 5 or 4. I'm not sure, but I think it's in both. Okay. On to the back, or the second page. Okay. This is just a multiplication problem. Nothing big there. You do have to show me work on that, though. It's not like you can just type it into your calculator. Your work must match. Okay. What is the largest number that divides evenly? You got to think about what that would mean. This would be a GCF question. So I know a lot of you are just going to want to circle the answer. But whenever we find GCF, I expect work, and you should know what work I require there. And if you don't show it, it will be wrong. Okay, this one. Okay. This one's this was an OAA question from a few years ago, but we like to keep it on because it's a good thinking question. Tell me how many blocks are in the 10th layer. Well, you can look here and see in the first layer there are 5 blocks. Okay, 1, 2, 3, 4, 5. Okay, well then in the second layer, you still have those same 5 directly below here. So there's 5 here, but now there's 5 here. So in the second layer, we know that we have 10 blocks. And then we have 5 here, 5 here, 5 here. It tells me there are 15 in the third layer. So I'm not going to go any farther, but I think you can kind of figure out what's happening here. Okay, and be able to figure out what the 10th row, how many are going to be in the 10th row without drawing out 10 rows. You could do it that way, but make sure you explain your answer there. Okay, back page. Okay, this is this is all chapter 5 stuff right here. This whole page except for I think the last one. Okay, this is chapter 5. As you can see, you are given right there a fake ratio. That's a fake rate. And we end up having to know, or we want to know, how much it would cost or how much she would pay for 8 ounces. So again, you must use a proportion to solve it. If you don't, it would be incorrect. Okay? This one, I would need to see 4 proportions on. Okay? So that means here's your fake ratio right there. So you would say, okay, A, I know that it is $1.60 per 1 ounce. And I just need to know, okay, I'm just going to calculate it. How much is 8 ounces going to cost? Okay, that's just what I'm going to find out. And if it's 20 cents, then I know this is the answer, or one of the answers. Okay, if it's not 20 cents, then I have done something wrong. Then it's false. So I look here and I say, okay, that's going to be times 8 there. That's going to be times 8 there. I mean, I can already tell you that this is going to be false, right? Because it's not going to get smaller. You're not all of a sudden going to buy more. You're going to buy 8 times more ounces and pay less money. So right there, I would write false next to that. Okay? So you're going to go through here and you're going to have a proportion for A, B, C, and D. And you're going to figure out which one of these would end up being the correct one. Okay? And then this one here. It's really just kind of a reading question here. Jackson analyzes polling results for elections across the country over the last 10 years. Jackson has correctly predicted the winner of an election 78% of the time. You need to pick the one you feel is the most accurate description of what that means. 78% of the time. Just keep in mind that all percents are out of 100, obviously. That's the whole. So keep that in mind when you're doing it. But other than that, I think that's a pretty easy question there too. Okay? And that's it. See you guys.